Hi, this is Indonesia. So I'm gonna do the second part of the video that I was talking about. So in the first video I covered about CNC programming, where I explained you about the engineering drawing, and I also explained you how to do a CNC program on a CAM software, which is MasterCAM 2018 that I used. So we'll now move on, and I'll show you how these codes that I've generated, I'm going to transfer it onto the machine, and then from there we're going to use those tools that I was talking about, and we're going to machine the real part. So let's get started on it. So this is the engineering drawing that I showed you before. Based on this, I had explained to you that I had created a process sheet. So this process sheet is something that an operator, a CNC machinist, goes through, and it's like a checklist for him to understand what are the operations in this particular machining process, and the work offset that he needs to understand, and the step over, the step downs, the tool diameter, the feeds and speed that he needs to be aware of. Now the most important aspect for a machinist is to know where the origin is. So I have also explained in this particular process sheet where the origin is. So I've explained X and Y is mean and Z is the top reference. So I've explained to you about this in my previous video about in the CNC programming. So let's get started to it. Okay, so I would like to give you some brief information about the tools that I've used. So if you can just see. So in here you can see the three tools that I've used is tool diameter 10 and flat end mill, then there is 4 flat end mill, and there's 3.5 drill. So this is a BT40 holder, this is a 10 diameter flat end mill, this is a 4 end mill, and this is 3.5 mil diameter carbide drill. Okay. And this is a part probe which we use to measure the work offset. So I'm going to shortly show you how that is done. And this is my stock material. So as you can see, I have a small scale in front of me. So it measures 65 by 50 by 25. Okay. So what I'm going to do next is, this is the machine's bed, and I've already dialed the vise, mechanical vise in here. I've got a height block. In here. So as you can see the height block. And what I'm going to do is, because it's only one part that I'm going to machine, I'm just going to put this part on top of it. Yeah. And before I start machining, I just need to double check that what is the depth that I'm going to go. So from the engineering drawing, I know that I'm going to machine it all the way till 15 millimeter. So just for safety preference, you always go and check that. So you check here that it's going to machine all the way to 15 millimeters. So I still have 5 millimeters of safety, and then so it's all good. So I can go ahead and machine this part. So just look for a mallet. So I'm gonna just observe what I'm going to do here is. So it's sturdy in here, and the mechanical vise is quite powerful, so it has exerting a lot of pressure, so this would not move when the machining is going on. Take this out. So the first thing that I'm going to do is I'm going to go ahead with the work offset. The next thing that I'm going to do is I'm going to take the work offset. So before that, I'm just going to explain you something about this machine. So this is a 3-axis machine. So if you have here, it has 3 axis to it. So we have the Z-axis. So the machine goes up and down. So I'll just show you how it works. So that's the z-axis. Then you have the x-axis, and then you have the y-axis. Okay. So this bed is it's a medium-sized CNC machine bed, and you can accommodate any component or part which is within 950 millimeters, like 500 millimeters, and you can cater 500 millimeters on the z-axis as well. So just a little introduction about the controller, how it works is, so this is an M80 Mitsubishi controller, and you have different settings into it, and this is the part where you can control the machine. So I won't go with the details, but I'm going to take the work offset using a part probe, and I'm going to put this onto handle mode, and then I'm going to turn this button. You can see that it's securely tightened. Then I'm going to use this handle ring. So because I have programmed it in such a manner that I've set the X and Y are mean. So there are different ways of taking tool offsets, so this is one of the most easiest ways. There are other ways as well. So the moment I see the red light, I'm going to capture this position and explain it to the machine where I am in the x-axis. So the way I do is I click on setup and I click on work measure. Then I click on the width measure. So what I need to do is I need to measure both the sides of the part. This point as well as this point, so it will give me the mean for x, and then I'll go on click on this point and this point on the y-axis, so I'll get the mean of x and y. So how I do is I'm going to first specify which coordinate system I'm going to use. So in this clutch sheet I've been told that I need to use G57. So I'm going to click on G coordinate and I'm going to click on G57. Okay. Okay, so I've explained to you that I had taken G57 as the work coordinate system, so I'm going to use the width measure and I'm going to specify where the x-axis is. So I can do that by taking skip position take in. So it has captured the x value, so I'm now going to use the handles. Come up. Skip take position. Now I'm going to take the right. Okay, so now for the Y, I'm going to again take the skip position taken. It has captured the value in here. Okay, so I'm going to again click on skip position taken. So all of my X and Y for position A and B is being captured. So I can now tell the machine where the X and Y mean is. I can do that by clicking on coordinate right, and it's asking me yes or no. Yes, so it has captured the value. So I can also confirm this if the coordinates are correct. So now in MDI mode, I just want to see if my work offset is correct. So I can just see if the work coordinate is correct by using a simple command. I written G57 X0 Y0 in MDI mode. So I'm going to show you how it works. So I'm going to cycle start and then release the so basically now I'm going to use the dial and go Z depth, so you can see now that it is at the center. The X and Y is at the center of the part. So I'm going to remove the full part and now, so since the work offset has been measured, the next thing that we're going to do is take the tool offsets for all the 5 operations. So I have 3 tools that I'm going to use. The first is the 10 flat end mill, the second is the 4 flat end mill, and the third is 3.5 diameter. So I'm going to show you how I take the tool offset. So while I was programming, I had mentioned that I've given a Z-top reference. So that means my reference for Z-axis is basically top in here. So I need to tell the machine where the Z location is. So there are different ways of taking a tool offset. One of the simplest way of taking a tool offset is the paper method. So this is a 50 micron thickness paper. So I'm going to use this and I'm going to take the tool offset for this. So how I'm going to do is take the tool here to the part. I was in 100 micron dial, now I'm going to go on 10 micron. Slowly place this paper on top of the part till the time I can feel that, till the time it tear off the paper. Now what I will do is I'm going to go on the coordinates and I'm going to go on G57. So this is my G57 and I'm going to input the value of Z in here by clicking on easy setting. I'm going to click on yes. So that's the value. So I have my X and Y and Z. Okay, so I have transferred the code onto the machine. So I'm going to see where the codes are. So I'm going to go and click on search. I'm going to click on D and op 1, which is the 10 end mill. So I click on this. So my program is in here, so I can click on edit and just have a final look if everything is okay. So yeah, so it's in G57, and all the information are correct. Okay. So and click on, I'm going to run the code 50 millimeters up, so just to see if everything is alright. So right now let's start. So it looks like the program is all good. So I'm going to reset, take the tool all the way towards up, go to coordinate, take the 50 out, which was the safety parameter, and I'm going to run this actual part.
Okay.
I'm releasing the feed. So it's machining in ramp with depth of 0.5 at the depth of cut. So you can see while I was explaining in the CNC program, it's the tool path that I showed you in the blue lines. It's following the same tool path, and it has a multi-pass right now. So it's taking out the material from the outside, and then the next pass is going to machine the part which is inside the profile that I really want, the 0.2 mm stop. So after that, we will go into machining the finishing pass, where the 0.2 mm of stop will be removed, and you get a really good finish out of it. You can see on the controller how the controller is reading all the codes, and you can see the speed, you can see the feed and the speed, and these are the codes which have been read here. So G57, G90, G01, G40, G49. So all of this has a specific meaning to it. And these are called preparatory functions. So you can have a look here. These are the codes and the machine codes, so you understand. So I've zeroed the feed in here. So I wanted to show you the multi-pass that I was talking about, and this is what it is. So the outside curvature is finished, so it's machining the inside one. So still it's the rough operation that is going on, and yeah, still the finishing part has to be done. So you can see the first and the second operation is done. So I've got the profile that I wanted to machine. Looks nice with its finish. Yep, so now we're going to go ahead and machine the operation 3 and operation 4 using the 4 end mill. Taking out the 10 end mill from the machine. So my first and second operation is done. Now I'm going to go ahead with operation 3 and operation 4, which is done using the 4 flat end mill. So I'm going to put this meaty holder onto the machine and take the tool offset once again. Handle mode right now. Basically, I'm going to do the same thing what I did with the 10 flat end mill. We're going to use the paper method, which is the most simplest method. So this is 50 micron thickness paper. We're going to switch from 100 micron to 10 micron increment. So now the machine knows. So here in setup or in monitor, go click the coordinates. So in G57 I need to replace. This was the position for 10 flat end mill. I'm going to replace this position. How I'm going to do is by clicking on easy setting. I'm going to click on yes. So I've got a new value in here, -37.360, and that's the position of the machine at the moment. Alright, so I'm going to take the Z up, and then I'm going to search for the separate code that I generated for the 4 end mill. So that's this program. I'm going to key in input. So I have the program opened up for me. Just going to go ahead with some fine checking. Some G57 work offset. Yes, pretty much everything is alright. Just need to double check if my toolpath is correct. So I can do that by using extension. So I give a 50 millimeter up on the toolpath so that I can run and just see if my looks good. The 4 flat end mill, and I'm going to click on cycle start, this green button, key in the feed, release the feed to 100. That much pressure for the 40 is not when you're running a 4 end mill. So I'm going to release the feed, and this operation is all about machining the pocket inside. so the operation 3 and operation 4 using the 4 flat end mill is finished. So I'm going to show you how it's going to look. Walk it inside. So this includes both roughing and finishing operation, and it gives a good mirror finish. Okay, so we're done with that. So I've taken out the 4 flat end mill, and I'm going to put the 3.5mm drill. This is a carbide drill, so because I have a carbide drill, I do not have to use a pilot hole. So I'm going to go ahead with this operation. This is the 5th operation. And I'm going to follow the same procedure. I'm going to take a tool offset. So I'm in heavy mode right now. I'm in 100 increment, 100 micron increment. Again, going with the paper method. And going back to 10mm increments. So I can see that I can tear off the paper. Now, I need to again go back on the coordinates, and I need to again specify the machine that there is a new tool offset to be taken. Because I'm not using, not going ahead with automatic tool changes, so that's the reason every time I'm changing the tool, I'm taking a new tool offset. Okay, so I'm going to click on easy setting and click on yes. So I have a new number in z-axis, minus 311.350. That's the new number. Now I'm going to take z-axis all the way up, search for the program that I already made. This is the program, the 3.5mm drill. Okay, so I've opened the program in here to just double check if all the parameters and codes are correct and the position is correct. So I can see G57 and all the header command is good. G98, G83, which is for peg drilling. So it's going to go 10mm deep and a retract of 3mm with a depth of cut of 0.2. The feed is 120, so it all looks good. So we can go ahead and machine this. So I'm going to click on the cycle start, release the feed. Okay, so we've machined the whole component. We have done the first op, second op, third op, fourth op and fifth op, and this is what it looks like. So I'm gonna take this piece out and I'm gonna deburr a little bit, and then we're gonna do some quality check and see if it matches the specification which is shown in the drawing. So that's the part which we had CNC programmed, and now it's machined. So if you open up the engineering drawing, you can see it's both the same. So, but since it's a parametric model, So we need to check if all the dimension which is specified in here is accordance to what's been specified in the engineering drawing. And yeah, we can go ahead and just do some inspection and see how it's done. Okay, so we machined the part, and this is what it looks like. I've got the engineering drawing, and this is a granite table. So this is a flat surface table, and I've got a couple of instruments in here. This is a vernier caliper. This is a height gauge, so I'm going to use a height combination of height gauge and vernier caliper to basically see all the dimension. So okay, so first of all, I'm just going to use height gauge to see this particular depth, which is 15 millimeters. So I'm going to check the height from this point all the way till this point. So how I'm going to do is I'm going to come here, I'm going to set to 0, so it's 0 at the moment, and I'm going to take it all the way till the up, and I'm going to take it right here. It's exactly 15. Okay, so that's all good. And then if I want to see what is the diameter of this hole. Okay, so it's 3.47. Just to take out a little bit of burr, and it will be all good. And so this is 20 by 20. So here you can see this is 20, so it's square, so 20 by 20. So I'm going to use the vernier caliper. It's coming out to be 20. Same for this side, 20 and 10 micron. So we have a tolerance of 0.1 here, so just good enough. Okay, yeah, so pretty much that's it. I hope you enjoyed the video. So I covered topics like making you go through the engineering drawing, then I explained to you how to use a MasterCAM software to generate codes that the machine can read. Then I took those codes and showed you how we can machine an actual component. And then finally we did some inspection with some inspection tool. So I hope you enjoyed the video.